Okay, so today we are starting chapter 11, which is on all about functions. So to start about functions, we need to get some definitions. We actually start with what a relation is, because a function is a specific relation. A relation is a set of ordered pairs that relates input to output. Now, remember, when we say ordered pair, it's just like we were talking about points on a graph. The way we write those, that is an ordered pair. So just a reminder of what that means. So what are these input and outputs? Well, the input is a number on which a relation operates. This is very similar to all those who've taken tech so far this year. You'll recognize these, input and output. And output is the answer after a relation operates on an input. So usually we talk about, like in tech, you have some machine. The input goes into the machine, and then what the machine does something to it, and what comes out is the output. In math, it's the same thing. Input, a number goes into this relation. The relation does something to it. It might add a number to it. It might multiply it by something, divide it, subtract, whatever. But it does something to that number, and then you get an output. Okay? And then we have a function, which is a relation where each input has exactly one output. There are some relations where if I put one number in, I could get multiple answers out. There are other ones where if I put one number in, there's only one answer that I can get out. If there's only one answer I can get out, then that is a function. If there are multiple answers for one input, it is not a function. And we're going to talk more about that today. A couple more definitions. Domain, that's all of the possible input values for a relation or a function, all the numbers that you could put in. And the range are all the possible output values for that relation or function, what the answers could be. That's all of our vocab for today. We're going to look at a couple of examples now. First example just says, is this relation a function? Okay, so remember, what it means to be a function is each input has exactly one output value. So what I look for is, do any of these input values repeat? If I have any of them that repeat, that means I can put one number in and get two different answers. None of these repeat. If they do not repeat, then the answer is yes, it is a function. Because each input, the -2, the 0, the 2, and the 4, each had one output. So yes, it is a function. Now I have another example. This one's written a little bit differently. It's asking the same question as a function, but notice it's written as ordered pairs now. When these are written as ordered pairs, remember these are like points on a graph, so the x-coordinates, the first ones in the ordered pairs, those are your input values. The 5, the 3, the 5, the 3. Those are all inputs. Okay? The outputs then are your y coordinates from the points. So the 1, the 7, the 2, I'm sorry, -2, and the 6, those are your output values. So now we can look at it and do any of these input values repeat? Well, yes, they do. I have two different 5s. One time I put 5 in and I got 1 out for an answer. Another time I put 5 in and I got -2 out for the answer. If I get two different answers by putting one number in, it is not a function. You'll also see that 3 repeats as well. So this is definitely not a function? The answer would be no, because one input gave me two different outputs. That's what you're looking for. So try this one on your own. Pause this. See if you think this is a function or not, and then start it up and I'll give you the answer. The answer is no, it is not a function. The reason being is I have -1 two different times. One time when I put -1 in, I got 6 for the answer. The other time when I put -1 in, I got -6 for the answer. So one input gave me two different outputs. It is not a function. That's all you have to look for on those problems, whether it's in table format or in ordered pairs. And the last thing we're going to do today, this wants us to find the output given a certain input. So we actually have 5 different input values. That's our domain. Remember, domain was all the possible inputs. So they're saying if you're using inputs of 1, 2, 3, 4, and 5, find the range, or all of the outputs, for this function. Y equals 2x plus 7. So the way we do that is by using a table of values. And this is what the table looks like. You have 3 different columns. Your first column is for your x values. Your second column is for your function. And your last column is your outputs, or your y values. So this tells me my domain, my inputs, my x's are going to be 1, 2, 3, 4, and 5. What I'm trying to do is figure out, when I put those numbers in, what are my output values. So all I do is put them in and just simplify. I do 2 times 1, which of course is just 2, plus 7, and that gives me 9. So that outputs 9. If I plug in a 2, I'm going to get 4 plus 7, which is 11. If I plug in 3, then I'm going to get 6 plus 7, which is 13. If I plug in 4, I'm going to get 8 plus 7, or 15. And when I plug in 5, finally, I get 10 plus 7, or 17. That should be a 7 there. And so my range, remember that's all my output values, that would be 9, 11, 13, 15, and 17. That is my range for this problem. That's all you do. You need to find outputs or a range given inputs or a domain. You use this simple table of values. 3 columns, your inputs or x's, the function where you actually sub in, and then your outputs or your y's where you write down the answers, and that's your range.